In today's video, we are going to be going over arc length. Now, I have two cases of solving for arc length. On the left, we have degrees, and on the right, we have radians. And I'm going to demonstrate how you can use either method to find an arc length. Or if a question would ask, how would you solve this in degrees? How would you solve this in radians? So let's start with the left side. Now, one thing I would like to point out is that the ratio between a arc length and the central angle is theta over 360 degrees. And so for this specific question, this is going to be S over C, right? The arc length is 9 over 2, and then the circumference, or C, is 10. We are going to make this equal to, we're going to in fact bring this down. This is going to be 9.5 times 110 equal to 9 over 20. To get theta by itself, right here, we need to multiply 360 degrees on each side. So theta is equal to 162 degrees, and that is the angle of this arc length right here. Now let's talk about this question using radians. It says an arc subtends a central angle measuring pi over 2 radians. Which fraction of the circumference is this arc? So the ratio here is going to be arc length over circumference. Which is equal to theta times r over 2 pi r. We can cancel out the radius here, and we are left with pi over 2 divided by 2 pi, which is the same as saying, we bring this down, which is the same as saying pi over 2 times 2 pi over 1 whoops. We want the reciprocal of this, so 1 over 2 pi. This is equal to 1/4. So the fraction of this arc is 1/4 the circumference. So I want you to take a minute, pause the video, see if you can solve these two questions right here. All right, now that you've paused the video to kind of take a look at this, let's go over this one first. It says a circle has a radius of 5, an arc in this circle has a central angle of 162. What is the length of the arc? Well, first we are going to calculate the circumference. So C 2 pi r. This is equal to 2 pi times 5, which is equal to 10 pi. So that is the circumference of the circle. It's 10 pi. Next, we need to remember that the ratio, right? The ratio between a arc's central angle and 360 is equal to the ratio between the arc length and the circle circumference. So theta over 360 is equal to the arc length over the circumference. And so we're given the angle 162 degrees over 360 degrees equal to, we don't know the arc length yet, but we do know the circumference, which is 10 pi. Right? And so now we have to get S by itself. We can first simplify this to be 9 over 20 equal to S over 10 pi. We are then going to multiply 10 pi on both sides. 10 pi. This gives us 9 pi over 2 equal to S. And we are done. That is the arc length. So this arc length right here is going to be 9 pi over 2. Now let's talk about this one. It says, write a formula for r in terms of theta for the following figure. The angle in the figure is a central angle in radians. So a central angle theta measured in radians tells us how many times the radius fits into the arc. We're going to take this theta equal to arc length over radius. We are now going to substitute. We're given the arc length here, which is 7 pi over the radius r. In order to get r by itself, because it tells us to write a formula for r, we need to multiply r on both sides. So we're now given theta r equal to 7 pi, and then we divide that angle theta on both sides. So we can get r equal to 7 pi